Ta-ding! 2 seconds, we're back. So now, of course, mix it all up. Crazy insanity, dogs and cats living together. All right, so I have 6, 8, and 12. So one of the things you can do is just multiply all the numbers together. I would not recommend that here because it's going to get big real fast. But 6 already divides into 12. So sometimes what I do when I'm trying to figure out the least common multiple is I take whatever the biggest number is and start going through the multiples till I find one that the other numbers also go into. So since 6 goes into 12 already, it'll go into any multiple of 12 as well. 8 doesn't completely go into 12. It's got some stuff in common, but not enough. So 12 times 2, though, is 24, and 24 is a multiple of 8. So that is what our common denominator is going to be. So we are going to turn all of these into 24ths. So to go from 6 to 24ths, it's going to be times 4. So this one is negative 20 24ths plus 8 to get to, let me change some colors. To get to 24ths is going to be times 3. So the top is going to be 27 24ths. Minus, I do times 2 to get to 24, so the top is going to be times 2. So minus 2 24ths. So negative 20 things plus 27 things minus 2 things. Now all the things are the same, I can crunch this. So negative 20 cancels out positive 20, leaving me with 7, and 7 minus 2 is 5. And 5 and 24 have nothing in common, so that is done. Now here, so the difference between these is actually like 2 versus 200. I need to multiply by 100. 20 versus 200 is missing an extra 0, so I multiply by 10. So it looks more intimidating than it really is. So we have 300 over 200 plus, and then this is going to get multiplied by 10. So 70 over 200 plus, and then this one already has 200, so we leave it. So 300 things plus 70 things plus 5 things is 375 200ths. Now, they are both 5 numbers, but pause before you start dividing by 5. I like to pause and are they quarter numbers? Which to me means if I change this into dollars and cents, is it quarters? So 375, can I count that in quarters? Yep. That'd be 2.00, $2. Can I count that in quarters? Yep. So we're going to divide them both by 25. So that's the kind of way to use your gut number sense with quarters to help you figure out what to reduce by. Again, if you just crunch it on the calculator, it'll do it for you. But here, all right, so $4 is 16 quarters. So 375 is 1 less. So that is 15 quarters. And then on the bottom, $2, 4 and 4 is 8 quarters. So we got 15/8. I know, I got weird tricks. Yeah. All right. I don't like this. I'm going to do the least common multiple by hand because my brain is not seeing a nice multiple straight off. So now we're, all right, I got 3 times 5, 5 times 5, and 2 times 9, which is 3 times 3. All right. So I need a 2, a pair of 3s, and a pair of 5s. A pair of 5s is 25. So let me write that underneath. So a 2, a pair of 3s, and a pair of 5s. So 25 times 2 is 50. 3 times 3 is 9. 9 times 50 is 450. All right. Now, we can use this prime factorization to actually help us figure out what we need to multiply by. So over here on my 15, I have a 3 and a 5. So I need to multiply by the other missing pieces. So a 2, a 3, and a 5. 2 times 3 is 6, times 5 is 30. So I need to multiply my first fraction by 30 over 30. So that will become 60 over the ridiculous 450. Minus, all right, 25 is my 2 5s. So I need to multiply by 2 times 3 times 3. 9 times 2, 18. So again, has to be 450 on the bottom. 6 times 18 is 6 times 6 times 3. 36 times 3 is 108. And then we have minus 18ths, which is a 3 and a 5. So I have a 2, a 3, and a 5. 6 times 5, another 30. Well, at least that multiplies nicely. 120 over the 450. Sorry, my brain is now looking at it like, that's not 18 times 30. It's not. Because the blue is not 3 times 5. Oh, sorry, guys. Downside of recording videos after writing a test. So 18 is the 2 times 3 times 3. So I need to multiply by 15. So 4 15s is 2 30s, so it's 60 over 450. It's not 15. Oh, that's what I'm missing. I can't read my own writing. I thought my 5 was a 3. So I need to multiply by 25, not 15. Good Lord. At least we are learning from my mistakes. So that's 100. The reason I paused for so long is I was seeing 60 over 450 minus 60 over 450, which would cancel, but 4/18 is not the same as 2/15. So that's why my brain was like, whoa, gut check, If the red and the blue fraction were going to cancel each other out, then they would also need to cancel each other out in the line above. 4/18 does reduce. We could have written that as 2/9, but it is not 2/15. So I apologize for my bad handwriting. All right, now we can crunch this. 60 things minus 108 things minus 100 things. I'm not writing the things, I was just doing the top numbers. Negative 148 over 450. All right. I don't know much about 148, but I know it's divisible by 2. So this gets us to negative 74 and 225, which is actually 15 squared. So 3s and 5s. Well, I know the 5s don't go into 74. Did the 3s? Well, remember our divisible by 3 rule. 7 plus 4 is 11, not 12. 3 doesn't go in there either, but you can check it on the calculator. 74 divided by 3 is 24 point blah, blah, blah. So that is our reduced final answer. Now I could start the video over again and do that so I didn't have the mistakes, but I am leaving the mistakes so you guys can see some of the mistakes you make and how to like check as you go and fix it, hopefully. It also kind of makes me look crazy, but so be it. We all knew I was crazy. All right. So this one looks ugly. It's not that bad though. Like we're not going to do much. So I have 2x and 2x squared, which is 2x times x. So they're almost identical, except I don't have that squared. The catch here is that doesn't mean I squared the first fraction. It means I multiply by another x, so it will become x squared. So we're going to multiply by x over x. So now I have 7x's on top over 2x squared minus 3 over 2x squared. So my bottoms are now the same, but my tops cannot be actually combined. 7x's minus 3 singles. I don't know what x is to know how that subtraction is going to work. So all we write on top is 7x minus 3. And the bottom just has the 2x squared. And we can't interact the x with the 7x with the 2x squared because we have that minus 3 wholes. Now, if it ended up being minus 3x, then we could have subtracted and then we could have reduced. But as it stands here, that's all we got. Now some application problems. So it's like, use your common sense to figure out what you're doing with the fractions. And what I do sometimes, because I don't like fractions, is I'll change them to whole numbers and figure out what I would do with the problem. And then I go back and just do it with the fractions on the calculator. So how many miles of electric pipe in total did Albert replace? He is repairing 3 houses. He replaced 1/4 of a mile, 3/8 of a mile, and 5/12 of a mile of electric pipe respectively. Albert is tired. But Albert, as an electrician, gets paid well. Unless the company is jerks and hiring people who aren't licensed, and then Albert is getting screwed over just like the rest of us by the capitalists. All right. But if he replaced 1 mile, 3 miles, and 5 miles, I know I'd just add those. 1 plus 3, 4 plus 5 would be 9 miles. But he did fractions, so the operation, the idea still holds. I just have to do it with fractions. 1/4 plus 3/8 plus 5/12. Now we've actually dealt with 8 and 12 before, but we had a 6. The 4 also divides into the 12 though, so, and it divides into the 8. So I really just need to figure out the number for 8 and 12, which you can glance back up was double 12, 24. So that is our first step, is turn this into 24s. And that would be 4 times 6. So this is now 6 24ths. And then to get to 8 to 24, it's going to be multiplied by 3. So we have 9 24ths now. And then the 12ths, it is times 2. So we get 10 24ths. So 6 and 9 is 15, and 10 more is 25. So he did 25 24ths, or 1 and 1/24 miles of pipe. All right. So this is what I meant about word problems. Like sometimes you answer with the mixed instead of the improper, because saying 25 24ths is weird. But saying 1 and 1/24 miles, you're like, oh, you did a whole mile and then one little extra bit. All right. We have a very ridiculous fraction. The figure shows students' success in a mathematics course delivered in 5 different instructional modes, meaning they looked at like 10 classes or something that were taught in different ways and then counted how many students succeeded. And then this is all those students who succeeded. This is the split on what class they were taking, what mode of delivery. So what fraction of students succeeded in the accelerated and modular instructional mode? So that is asking for us to do accelerated and modular. So the 3/20ths and the 31/60ths. Now, if you look at all these fractions, 5, 10, 20, 30, 60, all these smaller numbers can actually divide into 60. 5 will go in there, 10, 30, and 20 certainly do. So you could just change them all into 60ths just so you didn't have to keep converting on every little step. And then you can actually compare them a lot easier. But I'm going to head and do it per problem. So 20 to get to 60 is times 3. So this is now 9 60ths plus 31 60ths is 40 60ths, which is 4/6. And then we can divide that still by 2 and get 2/3. So I would say drawing not to scale, because I think 2/3 would need to be a little more over. Oh yeah, because the 1/30th and the 1/10 are almost the same size. Yeah, they just made 5 fractions so they could fit 5 pieces so they could fit the numbers in there. Totally not face to face. What fractions of students succeeded in the hybrid, online, and face to face? So let me pick a different color. Hybrid, online, face to face. So the math teacher in me says we should add those 3 fractions. But the smartass in me says this is supposed to be 1 whole. So if this is 1 whole and 2/3 are the pink things that we just calculated, then the other 3 are the leftovers. So it is 1 minus 2/3, which is 1/3. And that is totally legitimate thinking, perfectly correct, works every time because they asked for all 3 of the others, the other part, together. Now, if it was just 2 out of the 3, I'd still be crunching it by hand. And in fact, I can still do it by hand just to show you. So 5, 10, and 30, we only have to go to 30ths. So we would have 6 30ths plus 3 30ths plus 1 30th is 10 30ths, which is 1/3. And then the last one, find the perimeter. Meter is a distance, a length. So, and then all of my sides here are lengths. So this is add all the lengths. I should get an answer in kilometers, not kilometers squared. Areas are in square units. Volumes are in cubic units. Perimeter is a distance. So we're just going to add those all up, and they're all in eighths. Yay. So 3, 3, 3, 3. So that's 12. And then 5 and 5 is 10. So I have 12 eighths plus 10 eighths is 22 eighths. Which those are both even. And we get 11 fourths, which would be 2 wholes and 3 fourths left over. 8, 11 minus 8 is 3. And then we just stick on km. Alex may very well take like 11 fourths of a kilometer as well. And on the test, honestly, I would as well. It's just if you were going to like verbalize your answer, most people would look at you funny if you said an improper fraction to an answer to a question like this. All right. Cool. I'll post these and you guys will see them tomorrow because it's 11:14 for me.